we call that the sample mean x bar is equal to the sum of all the observation xi divided by the sample size lowercase n. Similarly, for the population mean, also called the mean of a variable, mu, the mean will be equal to the sum of all the observation xi divided by capital N, which represent the population size. For this problem, the mean mu will be equal to the sum of xi divided by n. So it's 62.5. Let's do it with a calculator. We go to Start, Edit, and then we start entering the data, starting with 73, enter, 67, enter, 68, enter, and so on and so forth. With the calculator, we'll be able to get the same results that we will get when we add all the scores and divide them by 18. It becomes a data entry kind of problem where all we have to do is entering the data and make sure we know which button to press to calculate the mean. We're going to enter the last observation, 57. Now we go to Stat. We click on Stat, then move on to Calculate and one variable Stat, and then we click Enter again. Now the very first one is the mean, the very first entry, 62.5, which is really 1125 divided by 18. Now here's how it works. The sample data is used to make projection into the population. A sample data of 50,000 US household is used to analyze the income of the entire US population. The sample standard deviation is the square root of the variance, which means it's the square root of the sum of all the deviations squared divided by n minus 1. Remember we said that n minus 1 dealt with the degree of freedom. Now, for the population standard deviation, it's exactly the same formula, but we have to divide by n, and because it's extremely large, we don't have to worry about the degree of freedom. We also have a computing formula where sigma, the population standard deviation, is equal to the square root of the sum of the observation squared divided by capital N minus mu squared, and mu represents the population mean. If we use the computing formula to get the population standard deviation, this formula right here, what we need to do is we need to calculate the sum of the squared observation, which means we'll have to square 73 and then add it to the square of 67, add it to the square of 68, and so on and so forth until the last observation, which is 57, added to 57 squared. Well, that sum is equal to 70,761. So the population standard deviation is equal to square root of 70,761 divided by 18 minus the mean, which is 62.5 squared. And the answer is approximately 5 kilograms. On the calculator, the standard deviation is sigma x, and it's 4.99. We use a sample data which usually consists of a small number of observations to make projections related to the entire population. It's very hard for a manufacturer to test the entire production of its company. Therefore, you will use a sample to project what the mean and the standard deviation of the entire population are. The mean and the standard deviation of the population are called parameters. For example, mu and sigma. And the mean and the standard deviation of the sample are called statistics, X bar and capital S.